Something impossible just happened in deep space. For exactly 12 seconds, every major observatory on Earth recorded the same phenomenon, a blinding pulse from a single distant point that shouldn't even exist. NASA's deep space sensors went dark, then reactivated, all locked on one coordinate. And when the data came back online, that faint flicker of light was no longer where physics said it should be. Because in those 12 seconds, the universe may have whispered something humanity was never meant to hear. July 2025. A faint, unremarkable speck appears against the black tapestry of space, silent, steady, and drifting through the solar system's outer edges. Astronomers name it 3I/ATLAS, marking it as the third interstellar object ever recorded. We've seen visitors before. Oumuamua in 2017, the strange tumbling shard that accelerated for no reason. Borisov in 2019, a comet-like traveler from some distant system. But Atlas refuses to behave. Its path curves where gravity says it shouldn't. Its surface gleams with an unnatural brilliance, and beneath that polished silence lies a story that threatens to rewrite everything we thought was settled about how the universe works. Because this isn't just another wanderer from the stars. What we've learned since its arrival doesn't simply bend the rules of physics, it breaks them one by one. At first, ATLAS was nothing more than a line of numbers, tiny fluctuations buried in the nightly data stream from an observatory in Chile. A junior analyst flagged it as routine, another speck of reflected sunlight moving too quickly to be one of ours. But when astronomers plotted its motion over consecutive nights, a quiet unease settled in. The trajectory didn't arc like a comet's. It sliced, clean, precise, through the solar system's outer rim at a velocity no natural object should sustain. 152,000 miles per hour. That's 5 times faster than anything we've cataloged drifting through our cosmic neighborhood. It wasn't being pulled, it was passing through, as if the sun itself were nothing more than a waypoint on a much longer journey. Telescopes from Hawaii to the Canary Islands confirmed the same thing. A TLAS was not bound by our star's gravity. Its orbit was hyperbolic, an open curve that begins somewhere beyond the reach of any known planet and never returns. When researchers traced its path backward through simulation, the coordinates dissolved into nothingness. Interstellar space, the endless dark between suns, no parent star, no known origin, just an object older than the solar system itself, wandering for eons until chance brought it here. Yet even in that silence, something about it felt deliberate. The light it reflected was steady, unnaturally uniform, its rotation measured like clockwork. Instruments expected random flicker. Instead, they found rhythm, a pulse hiding inside the noise. By mid-August, data poured in faster than teams could process it. Spectrographs hinted at chemical compositions no one could quite believe. Observatories began coordinating around the clock, chasing a traveler that seemed to defy every equation meant to describe it. For weeks, it remained only that, a mystery of motion and mathematics. Until one quiet morning, when radio telescopes listening across multiple continents registered a single razor-sharp burst from the direction of ATLAS, and then it spoke. For the technicians on the night shift, it started as background static, a thin hiss that rippled across the spectrum like distant wind. The Very Large Array in New Mexico was midway through its calibration cycle, its dishes sweeping the sky in perfect synchrony, when one channel spiked, then another and another. Within seconds, every antenna listening on that frequency froze on the same coordinate, 3I/ATLAS. At first, no one panicked. Cosmic noise is fickle. Solar flares, passing satellites, even lightning on Earth can masquerade as deep space signals. The team logged the anomaly, tagged it for review, and continued their scan. But the waveform refused to fade. It sharpened, narrowed, began repeating. Across the ocean, an observatory in South Africa detected the exact same burst down to the microsecond, then one in Japan. The global network triangulated its source, and all vectors traced back to a single moving object halfway between Mars and Jupiter. The pattern unfolded like a heartbeat, 3 short pulses, 1 long. Silence. Then a longer series, rising in frequency before vanishing altogether. The sequence lasted precisely 12 seconds, long enough to rule out random interference, too deliberate to dismiss. Theories exploded across the control rooms. A solar flare reflecting off metallic debris? Impossible. No such reflection repeats across continents. Equipment glitch? None of the instruments shared hardware or software. Cosmic ray interference? The probability was astronomical. Hours later, data packets from independent amateur arrays confirmed the same event. The signal was genuine, coherent, and, most disturbing of all, self-terminating, as though it recognized when it had been heard. When researchers ran the waveform through analytical filters, they found embedded harmonics spaced in perfect Fibonacci intervals, a mathematical fingerprint rarely produced by nature. Still, no one dared say the word intelligent. Not yet. The official report called it a non-recurrent narrowband anomaly. But inside every lab, the same question hung in the air, because once could be coincidence, twice would mean intent. When the James Webb Space Telescope fixed its gaze on 3I Atlas, the first surprise was its brilliance. Most comets scatter sunlight unevenly, rough, fractured surfaces, diffusing it into chaos. But Atlas reflected light as though it were polished. Photons bounced back in uniform streams, too consistent for a natural body battered by cosmic debris. Some analysts compared it to aluminum, others to titanium alloy. None of those materials should exist in such purity beyond Earth's foundries. The object's albedo, its reflectivity, was off the scale, gleaming brighter than ice under direct noon sunlight. And so the question emerged, has nature learned the art of mirror making? Or are we staring at craftsmanship on an interstellar scale? Natural bodies tumble. They spin unevenly, wobble through the dark, their momentum scarred by ancient collisions. Yet Atlas moved with the poise of a metronome. Every rotation completed in exactly 1084 hours, never faster, never slower. Orientation sensors recorded an angular drift so small it bordered on mechanical stability. Even stranger, its axis maintained a perfect alignment with Earth during peak observation windows, as if the object understood where our telescopes were. In astrophysics, randomness is the rule, perfection the anomaly. Either we've discovered the universe's most disciplined comet, or something within Atlas keeps time more faithfully than any clock we've ever built. Infrared imaging expected the usual thermal map, sunlit surfaces warm, shaded regions cold, but Atlas defied that model. One hemisphere remained consistently hotter than the other, even as it rotated away from the sun. The temperature differential held steady, precisely maintained, as though energy were being regulated from within. Scientists proposed exotic explanations: trapped gases venting cyclically, friction from internal cavitation, maybe unknown isotopes radiating heat. None fit the data. To sustain that balance would require intention, like a vessel distributing warmth through hidden radiators. The cosmos, it seemed, had developed thermal management. Spectrographic analysis shattered expectations. Where most comets exhale water vapor, Atlas exhaled carbon dioxide, 10 times more than any previously recorded ratio. Iron, the backbone of rocky matter, was virtually absent, replaced by torrents of nickel and trace platinum. Carbon compounds appeared too structured, molecular chains arranged in repeating patterns rather than random clutter. Some mirrored the geometry of synthetic polymers. Impossible, one chemist whispered during review, but the instruments were calibrated, the readings were real. Nature can surprise us, but molecular order of that complexity usually has a designer. What kind of world forges a comet out of metal and symmetry? As radar mapping probed its core, signals bounced back with unexpected delays. Instead of a dense nucleus, reflections hinted at vast cavities, hollow chambers scattered through its interior. Density models collapsed under the evidence. Atlas wasn't a solid monolith, but a shell. Every simulation of natural formation failed to reproduce it. Gravity should have crushed such voids billions of years ago. Unless, of course, those spaces weren't flaws at all, but deliberate architecture. A hollow body is fragile, yet Atlas endures interstellar speeds unharmed. Whatever it's made of, it was built to survive the void. By September, deep space tracking revealed the final anomaly. The object's path changed minutely, elegantly, without visible propulsion. Each correction measured mere fractions of a degree, timed perfectly with Earth's best observational windows. When our telescopes aligned, Atlas adjusted. When clouds or daylight hit it, motion ceased. Analysts blame sublimating gases or radiation pressure, but those forces act continuously, not selectively. The precision was uncanny. Something or someone seemed to prefer being seen. The anomalies stacked one atop another. Reflectivity, rhythm, heat, chemistry, hollowness, and now movement with intent. Individually, each might be explained away. Together, they formed a pattern that resisted every natural law we know. And then, just as the data streams reached their peak clarity, access vanished. Files locked, feeds cut, observation logs sealed under new authorization codes. That's when the data went dark. Within hours of the last transmission, the open data feeds from every major observatory flickered, then went black. The live dashboards used by universities and independent researchers began returning empty graphs, no telemetry, no thermal readings, no light curves. Access requests timed out. Passwords that had worked for years suddenly produced an identical message across systems, authorization revoked by administrator. At first, scientists assumed a glitch, a server crash, maybe a network update, but as the night stretched on, it became clear this wasn't technical failure. It was lockdown. NASA's Jet Propulsion Laboratory restricted its Atlas folder to internal clearance only. The European Space Agency mirrored the action within hours. Even the shared cloud mirrors that stored public data were wiped clean, replaced with blank directories bearing fresh timestamps. Emails circulated quietly between teams. Did you lose access to? Every answer came back the same, yes. Then came the official statement. Due to potential cross-contamination of classified aerospace telemetry, certain data streams relating to Object 3Y Atlas are temporarily withheld pending review. Classified telemetry? For a comet in the scientific community, that phrase landed like a thunderclap. Why invoke national security over a celestial object millions of miles away? What exactly could a lump of ice and dust threaten? Privately, a few researchers admitted they had seen fragments of the last unfiltered spectra before the blackout, readings that didn't match any known material library, patterns that looked organized rather than random. One described it as signal folded into substance. Another simply said it wasn't behaving like matter. When Freedom of Information requests began to pile up, the responses arrived months later. Documents heavily redacted. Pages reduced to black bars and boilerplate language about ongoing investigations. Entire observation schedules vanished from public archives. A few astronomers were reassigned to unrelated projects without explanation. And still the question lingers in every hallway whispered between colleagues long after midnight. What did they find in those final spectra that demanded silence? Because whatever it was, no one outside those locked laboratories has seen it. For now. The truth about 3I/Atlas exists in two competing realities. In the first, it is a miracle of nature, a wanderer born in a distant stellar nursery forged from chemistry. Our solar system has never seen a relic of a different sun, carrying within it the story of worlds long extinct. If that's true, Atlas forces us to rewrite astrophysics from the ground up. It would mean the universe is far more diverse, far more creative than our narrow models ever imagined. But there's the second possibility, the one no one dares to put in an official report, that Atlas isn't a comet at all, that the uniform surfaces, the stable rotation, the controlled heat, the hollow structure, even that 12-second transmission, are not natural coincidences, but signatures of design. If so, this would not just be a discovery of cosmic proportions, it would be the first confirmation that intelligence beyond Earth exists. And it has already reached us. Two futures stand before us. In one, we expand our science. In the other, we expand our definition of life itself. And here's the paradox. Either outcome ends humanity's perception of isolation. Because whether Atlas is a masterpiece of cosmic physics or the creation of a distant mind, it proves a single truth. The universe is not silent. It has structure, story, intention. And as we look upward, searching for answers among the stars, perhaps it's time to accept a humbling possibility that the cosmos has already begun looking back. Step back for a moment and look at the timeline. For billions of years, our solar system has been a place of peace and harmony. System was quiet, no confirmed visitors from beyond. Then suddenly, in less than a single decade, 3 arrived. First came Oumuamua in 2017. The elongated, tumbling object that accelerated without a visible engine, it defied every model, as though pressure from sunlight alone nudged it forward. Scientists called it a fragment, a shard, an accident, but no one could explain why it changed course after passing the sun. Then in 2019, 2 I/Borisov entered. Faster, brighter, a more traditional comet, but still unlike any we'd ever cataloged. Its chemistry didn't match anything local. Its dust carried signatures of alien star systems. It was, for a moment, comforting, proof that nature can be strange without intent. And now 3 I/ATLAS, combining the mysteries of both. The structure of Oumuamua, the chemistry of Borisov, and new anomalies no one saw coming. Internal heat, metallic composition, deliberate motion, 3 arrivals, 3 data points, a progression. What are the odds that interstellar visitors would appear in such rapid succession, each one more complex, more provocative, more deliberate than the last? Some scientists have begun to whisper a quiet hypothesis. What if this is not random? What if it's a pattern, a sequence of contact carefully escalated to test our perception? Not an invasion, not even a message, but an evaluation, a gradual introduction designed to measure how we respond to the unknown. Oumuamua asked if we could notice motion. Borisov asked if we could recognize difference. Atlas now asks if we can confront design. We can't prove it. We may never be able to. But the data keeps leaning toward intelligence, or at least intention, because each object seems to know exactly when and how to be seen. Each one meets us at the edge of what our instruments can comprehend, then retreats into silence. Maybe this isn't the universe sending us random artifacts. Maybe it's conducting an experiment to see if we're ready to listen. Or worse, maybe we're no longer the observers. Maybe for the first time we are the observed. Science was never meant to comfort us. Its purpose is to face the unknown, to ask questions that might change everything we believe. For centuries, we've stared into the stars, thinking we were alone. But 3 I/Atlas reminds us when we observe the universe observes us. Each anomaly, each signal forces a choice: turn away or keep listening. Fear closes the telescope. Curiosity keeps it open. And that's how progress begins, not with certainty, but with courage. Now, as Atlas drifts deeper into sunlight, our responsibility is simple. Keep watching. Demand truth. Refuse silence. Because the real danger isn't what's out there, it's choosing not to look. Maybe Atlas is a relic of nature. Maybe it's a messenger. Either way, it's already done the impossible. It made us listen. Because somewhere in that silence between the stars, something is watching, waiting to see if we're ready to listen.